Alright, for our project today, we did a basic heat exchanger with PVC piping that we had ran through a cooler, and basically the inlet temperature fused inside the PVC pipe with the temperature inside the cooler and changed with the outlet temperature. And by using two different ends, we dropped thermometers into to check the temperatures, and that we were then going to use the K value for PVC and all the specs on the PVC and the temperatures, and we were going to solve for our final Q values of heat transfer.
My first best friend was a six string. Took him with me everywhere I go. When I was 18, bought a Dodge van, found a drummer and made the road my home. Ooh, I wouldn't change. You're as cold as ice. You're willing to sacrifice our love. You never take advice. Someday you'll pay the price. I know. I've seen it before. It happens all the time. You're closing the door. You leave the world behind. You're digging for gold. You're throwing away a fortune and feelings. But someday you'll pay.
For our project, for the cooling portion, we had the 44 gallons per minute at our high flow rate, and then we had a 25 gallons per minute for our low flow rate. For our high flow rate, we had an inlet temperature of 69.5 degrees, while the cooler was being 34.5 degrees. We had an outlet temperature of 67.8 degrees. And for our low pressure inlet, we had 69.5 degrees, and the cooler was still the same at 34.5 degrees, and our outlet was 66.7 degrees.
So as you can tell from that, with a faster flow rate, we got a little bit of a higher temperature than that of the lower flow rate, because the water was able to go through the heat exchanger and the cooler at a slower rate, and that caused the temperature to be able to drop lower.
For the hot water test, we had the same flow rates as the cold water test and the same inlet temperature, but this time the water inside the cooler was 132 degrees Fahrenheit, and our two outlet temperatures were 75.5 and 78.3.
So once again, like the cold water temperature test, our lower flow rate had a more drastic temperature change because the water stayed in the piping system longer. Alright, so for our final equation for heat transfer, it was this one right up here, Q equals 2 pi L times delta T over the natural log of the ratio of the outside diameter and the inside diameter times our K value of PVC. We had a total length of 170 inches, which was into feet 14.16 feet. We had our two values for our radiuses and all of our change in temperatures for each of the four chances. Our K value of 119 and we got our four values of 96.7 watts, 159.28 watts, 341.317 watts, and 500.598 watts. And they increase in wattage as we go down because at each test, the variance in temperature increased.
Change a thing. It made the man I